All right, hi everyone. Okay, for those of you who don't know me, my name is Miss Ho, and I'm doing this video in preparation for not being in class. So I hope that you find this video helpful in figuring out how to answer these questions. Right, let's begin. I've prepared the diagrams but not the numbers yet. So I'm just going to write the number really quickly. Okay, there's no A, but never mind, we'll just go with it. All right, so for this particular question, I don't think that any of you should have any problem with this. I'm just going to type the answer here. I'm going to put this in blue so that it's clear that that's the answer. I'm going to make this a bit larger. So the resultant force, in this case, of course, is when you do vector sums, remember to add the forces that are in the same directions together. So that's why resultant force is basically 7 plus 3, giving you the answer of 10 Newton. Easy peasy lemon squeezy. I don't think any of you have a problem with this particular question. Okay, cool. So for the next one, which is this question, again, same thing, you have to do vector sum. So you add all the forces that are in the same direction and you minus those that are in the opposite direction. So the resultant force is 1 plus 2. If we take to the we take it to the right, your right is this way. Yeah. Okay, you go to your right, that would be positive, and to the left is negative. So that's why it's 1 plus 2 minus 5, giving us a value of negative 2 Newton. Negative 2 means what? Negative 2 means to the left. Easy. Next question would be this. So because these forces are acting perpendicular to each other, you need to solve this using Pythagoras theorem. So we'll just get straight to the answer, which means that the resultant force, I'm going to write this out because I can't do square root with these numbers. But I'll just type this in here first. So it's square root of 8, whoops, 8 squared plus 6, right? So I'm just going to add the square root. Square root, come. Okay, square root here because Pythagoras theorem, right? So that gives us an answer of 10 Newton. Now, of course, ideally you should draw the triangle out or the parallelogram out so that you can show the angle. Because I know a lot of you just going to write this. You're going to write, okay, theta is inverse tangent of 6 over 8, and that's how you get 36.9 degrees. Actually, no. So I'm just copying the answer from your book. If I'm mistaken, oh, my mouse is not working. If I'm mistaken, it's 36.87. Yeah. So remember that in physics, you always want to write your answer to 2 decimal places for SPM. Right, so it's 36.87 degrees, but you should mention which direction it's moving from. So it's 36.87 from the 8 Newton line. So the best thing to do is actually to say clockwise from 8 Newton. So because it's going, wait, in your direction, it's going this way, right? Ideally, but I know most of you are just going to write the number. That's fine if you could just draw and indicate where theta should be. So these are your answers for question 1. Okay, so let's go to question 2 now. Okay, it's heavily raining, so I think you're hearing thunder as well. So for question 2, you need to solve this using the scaled diagram method. And you can choose to solve this either using the triangle method or the parallelogram method. So I'm going to sketch both. And you should be drawing this to scale, which means you should use your ruler, measure the length out, and use a protractor to measure the angle out. What I'm going to do on the board here is to do a sketch to show you how your parallelogram and triangle should look like. On your own paper, it should be to scale. So you don't have to do both, just pick one, but I'll do both so that those of you who did parallelogram, you can check, and triangle, you can also check. So if you did a parallelogram, it should look like this. Oops, sorry, wrong pen. You should have this and this. Use your protractor and measure out of 40 degrees. And then, okay, same thing, measure out 40 degrees and then parallel line. But remember, parallelogram, these must be dotted, and only these forces are labeled. Label with the original force numbers 4 Newton and 5 Newton. And the resultant force is from corner to corner, which is this. And remember, resultant forces are labeled with double arrows. So this is with the parallelogram method. If if you're using the triangle method, then 5 Newton force first, measure out the 40 degrees. Okay, then here's your 40 Newton, and your resultant force is from tip to tail. So this is the resultant force, and this is what it would look like if you use the triangle method. So whichever method you use, what you need to do is you use your ruler, measure the value of r out with the ruler, use the scale to get the number back, and measure these angles, which I will label as theta. So based on this, your values, well, the values you should get should be approximately about 8.5 Newton, and the angle theta, let me get the theta symbol, is approximately 18 degrees. Now, I'm looking here because the answers are in the teacher's edition, so I'm just copying it off the teacher's edition. Okay, but if any of you happen to get values that are a little bit different from this, like if you got 8.4 Newton, 8.6 Newton, or if you got angle maybe about 20 degrees, normally when you do scale diagram, there is a range of answers. So it's not like, oh, these are the only answers for scale diagram, because sometimes some allowances are given for any slight errors and all that. So normally they're quite flexible. As long as your number is around here, around these values, it is normally accepted. As long as it's not too far away, like if it's 8.5 Newton and you got something like, 10 Newton, then that's too far away. 18 degrees, you go and measure, you get like, 15 degrees, and 3 degrees is a little bit too big. So as long as it's close enough, it's normally accepted. Okay. So along the same lines, you solve this question. Again, I'll do both so that you can check, both meaning parallelogram and triangle. So if you're drawing a parallelogram, that means you complete the parallelogram like this. Okay, remember, dotted line, because these are not the actual force lines. And your resultant force is from corner to corner. Okay. This is the parallelogram method. So if you're using the triangle method, then it's one force followed by the other, and from tip to tail. Remember, by the way, you should be drawing in pencil. If you're drawing with pen, habis, salah already, okay? Rejected outright. You should be drawing all these in pencil. Same thing as before. To get a value of r, you use your ruler and measure. And angle, let's label it here. Use your protractor to measure. Here are the values that the book suggests that you should get. Resultant force is about 9.2 Newton. And the angle, let me just get the theta again, is about 48 degrees. So just like before, if you're getting a value that's slightly different, like you're getting 9 Newton, 9.1, 9.3, around there, and they normally accept. If you got, say, 48, you got 49 degrees, 47 degrees, also acceptable. All right, as long as it's not too far away. If the number is too far off, then maybe you want to check whether the angle that you've measured out, the parallelogram you've drawn, is it really parallel or not? You may just want to check on that. Okay. All right, that's up to question 2. So now let's go to question 3. Let me label question 3. Okay. So for question 3, what they want you to do is they want you to fill in the blanks, and this is how it goes. So we have, I know I've done the drawing here, but I didn't write it out. So let me just very quickly just type it out for you. Okay, so here's what you want to fill in. So we have resultant force of F unknown, and they say minus G, where G is the frictional force. Now they didn't draw it in the diagram. I highly recommend that in your own book, just label G anyway for your own reference. So whatever I label in blue here is what you can write and what you can add. All right. So the resultant force, you can see, right? If it's minus G, that means it is the forces, forward force minus a backward force. So there are only two forces here. Therefore, it's 8 Newton minus G. I'm going to change this to blue so that you can see. Right? Because when you're calculating resultant force, you're counting it based on the forces in the free body diagram. That means you plus and minus all that. So there are only two forces, the forward force minus the backward force. That's why 8 Newton minus G. Now for the second line, they want you to use F equals MA. Oops. F equals MA. And they want you to again fill in the blanks. Minus G equals to MA. Oops. Okay, let me just drag this out. All right. And, oh, what am I doing? Sorry, not this. Okay, this one. Okay, so what you need to go to put in here is, so F we know is a resultant force. That means this side will go here. And this is your MA. So the numbers that go here, this will be 8 Newton minus G and MA. So M is 2 and acceleration is 2. Therefore, it becomes 2 times 2. So this, in the end, gives us, okay, let me just write this out first. So in your book, it's like this, right? It's G equals to blank blank. Okay? Equals to blank. So what blank? They just want you to move things around. So by right, if you're pretty good at maths, you can already figure this out. You already know that G is 4, but never mind. We'll just fill in the blanks here, like how the book wants us to do it. So it's basically shifting around. You get 8. What is it? 8 minus 4. And in the end, your final answer is 4 Newton. And that's how you solve it. All right. So remember this way. Resultant force, you need to have one statement where you have all the forces plus minus, so that 8 minus G, forward minus back. Then there's another statement, F equals MA. This F and this F are the same, so same value. So that means this one can be substituted into here. That's why it goes on the left-hand side. And that's how you get the MA. Okay? All right. If you have any questions, of course, please write down the question or just highlight the number so that the next time I see you, you can ask me and I can clarify for you. Okay. Next, question 4 is about the lift. So there's 3 questions here, 1, 2, 3. Let's start with number 1. So for number 1, it says here that the lift is moving upwards with constant velocity. So I'm just going to write here constant velocity as a reference. Okay, constant velocity. All right, so for constant velocity, it means that acceleration is 0. So if you like, you can just add here, okay, for your own reference, a equals to 0. So what this tells us is the resultant force, F, okay, it's moving upwards, right? It says, yes, it's moving upwards. So that means we can think, okay, it's moving upwards. Normally, if it's moving upwards, that means that the upward force is more than the downward force. So you can write it as R minus W, right? But because the moving with constant acceleration is 0, oh, it's already mentioned in the next line, right? So therefore, when you substitute it into F equals MA, just like in the question before, R minus W goes inside here on the left-hand side. So we can have R minus W equals mass times 0 acceleration, right? So that means 0 lah. So 0 times 0, 0, okay? So that means in the end, you have R equals W. What is W? Mg. Okay, how much is mg? Now, m is 60 according to the question, and g by right should be 9.81. But the question told you to use g as 10 Newton per kilogram, because that's what the question tells us to use, you have to use it. So that's why we'll use as 10 for this question. So that's why you get 600 Newton. And that's the answer for this question. Okay, I think I used up the whole space, so I'm just going to create another blank slide here. All right, and then for question 2, same question. So it's nice to same diagram, but this time it's moving upwards with deceleration of one. I think I'm just going to write this out. Malas to type really. Deceleration of 1 meters per second squared. So the resultant force F, because it's still moving upwards, right? So it's still moving upwards, we still take R as bigger. That's why it's R minus W. Now substitution into F equals MA. You have R minus W equals to M times, well, it's decelerating, right? So you can put -1. And that's why when you solve this, you have R minus mg equals to -m. If you can substitute in straight away with numbers before this, you can go right ahead. I'm just writing it step by step. So you have R, R minus 600 equals to -60, and that's how we get, bring it over, 540 Newton. Okay, and to solve number 3, oops, sorry, change pen. Number 3, it's moving downwards with the constant acceleration. So I'm just going to draw arrow going downwards, right? This is going upwards, yeah. So it is accelerating. I'll just write A over here, 2 meters per second squared. So in this case, because it's moving downwards, we can assume that W will be greater than R. That's why it's W minus R. So our substitution into F equals MA, we will get W, whoops, what was that? W minus R equals to MA, where W is mg. I can should have substituted away. So my 600 minus R equals to 60 times 2. So you bring this around, ding bada boom, and then you will get 480 Newton. All right. Okay. I was going to ask if any questions, but if you have questions, you ask now. I can't hear you to answer anyway. So if you have any questions, remember, highlight the number, and then we'll discuss it the next time I see you guys. Okay, but that's how you solve question 4. Now for question 5. Okay, so for question 5, not complicated. It is a little bit different from the way the textbook solves the questions, but doable. All right. So let's answer. So you have A, B, C. A is the resultant force. B, they want you to count the acceleration of the system, and C is the tension of the rope. So let's do this one by one. Whoops, change pen. All right, so to solve the resultant force, okay, in this kind of question, let's say you have to solve the entire system, then what you do is you just look at all the forces acting here. So what are the forces we have? We have the weight, we have tension, and we have the frictional force. So although it's acting like, hey, apa ni, not straight line, perpendicular, but they're still kind of moving in the same direction, because this is, when it moves to the right, when this 10 kg moves to the right, this object is going to move downwards. I think I forgot to indicate this is 5 kg. So I'm just going to add that in because saja to make it complete kan. Okay. So yeah, that's more correct. Okay, so you have a situation here where it's on a pulley system, although they don't seem to be in the same direction, but they're still moving as one unit, because when this object moves downwards, this object will move to the right. So you can take this as one system. So what are the forces acting here? W, T, T, and G. But if you look at it, hey, these tensions are canceling each other out. So if I want to write it in full for your reference, you can think of it as, okay, moving down, right? The resultant force is W minus T then this T same direction as W actually, even though it's like this, it's actually moving together, right? Same direction plus T minus G. But if you look at this part, you see this T will just cancel each other out. So actually you can just ignore it. So if you didn't write this, that's fine. Just write W minus G is fine already. So I'm just writing this in full for the benefit of those who want to understand the diagram. But essentially you can just write it as W minus G. So what's W? Okay, the W is this W, not this W, yeah, because this weight is not part of the system. We're looking at this W only, okay? So don't ignore this blur, okay? So this is where you'll get 5. We'll take, because we're following up question 4. By right, G should be 9.81, but never mind. Because it's a follow-up from question 4, we just take 10 minus G of 10. That's how we end up getting 40 newtons for the resultant force. If you used G as 9.81, it's actually more accurate. But I know some of you have used 10 because of question 4. Okay, so I'll leave it as 10 for now, but by right should be 9.81. Okay, so this then gives us acceleration. Oh, I forgot to change pen. Acceleration of F equals ma. This is the resultant force, right? So 40. Now, for this case, you don't just take 5 kg because this is an entire system. So if you're talking about the entire resultant force, you must take the mass of both of these together. So that's why you must put both 10 plus 5 times A. And that's how you work it out. You'll get 2.67 meters per second squared. Please remember, for physics SPM, you must write your answers to 2 decimal places. Don't round up to just 1. All right? Okay. And I need more space. I'm going to create another slide. Then to solve C, whoops. To solve C, you want to count the tension of the rope. Let's go back to this diagram. To calculate the tension, now we can't take the whole system because, meaning you can't take the system as a whole, because if you're trying to use the forces, you see how, cancelled out, how to count T. So to count tension, the only way is to split this system into 2 and isolate left side only or right side only. Okay, so what do we mean by this is we split, focus on one, ignore the other. So let's say if I take this side. So I'm just going to draw that out. So we have this, okay. And what we have? We have the weight here, which is 50 Newton. And then we have tension, which is unknown. And we know the acceleration of this object. Now we know it's 2.67, right? 67 meters per second squared. That's acceleration. So when you want to calculate the tension, you take it as F equals ma and focus only on this part. Now, this object is moving down, right? So if it's moving down, that means weight is more than tension. So W minus T equals to ma. And then you can solve. Okay, 50 minus T equals to mass, which is 5. Only this object, right? 5 kg times 2.67. And that's how you get tension of 36.5 Newton. Now, what if you didn't take this object and you want to take the one that's lying on the table? Does it work? Yes, you will get the same answer. So you don't need to do it 2 times, but I will show you as proof, just in case. All right. So let's say you take the object on the table instead, which is 10 kilograms. I realize I'm using the wrong pen, but you know what? Too late. I'm going to go with it. This time we have tension, and then we have G 10 Newton. We know the acceleration is 2.67 meters per second squared. So from here, F equals ma because it's going to the right. Therefore, T is more than the friction. So T minus 10 equals mass, which is 10, acceleration 2.67. Okay, you count. You will still get the same answer, which is 36.5 meters or thereabouts. Okay, I'm just copying this off the book, okay? So if it's slightly 36 point something, it should be about the same. All right? Okay, so for the final question, which is the pulley question. Okay, so same thing. We will calculate the resultant force first. Again, you can treat this as a whole system, because if this object moves down, this object moves up together. You gotta move together. Where's the camera? They move together, right? This one go down, this one go up. So together. So just like before, if you want to calculate the resultant force, you look at all the forces in this diagram. You'll find the tension cancels itself out. So if let's say we see going down, so we this way, that means this weight, which I'm going to label as W1 and W2. Otherwise, it's really confusing. Yeah, your book doesn't write it, but never mind. So I can write it as W1 minus T. Okay, then this side is same direction, right? So plus T is T. Okay, minus W2. So again, this part you can cancel, right? So it becomes just W1 minus W2. That means this weight minus this weight. That means it's 10 times 10, if we're taking G as 10, okay, minus 5 times 10, and that's how we get 50 Newton. So then to calculate acceleration, like before, take the system as a whole, F equals ma, where now this resultant force is 50. So because we're taking the entire system, that's why the mass also we plus together. So that's why it's 10 plus 5, and then you want to count the acceleration. This gives you about 3.33 meters per second squared. So then to calculate the tension, you can, again, like before, split into two. So left side only or right side only. You will get the same answer. So I'll show you both. So let's say, for example, we take the left side lah. Okay, left side. So we know that this one is going down. Okay, so this one is 100 Newton. Acceleration downwards at 3.33 meters per second squared. And there's tension upwards, right? Okay, so F equals ma. Because it's going down, that means 100 is more than T, and mass is only this object. So if you're isolating like this, you only look at this object, you ignore the others. So that means only 10, and then times 3.33. Count, you should get about 66.5. Well, that's what the book says. You could be getting another number. I'm just going to go with it first. Okay. So if you try to take the other side, let's say you're like, oh, teacher, I took the other side. Then I don't really get the same answer, okay? It's just that the directions are different, no? So you take note of the direction, right? So like this one, this is 50 Newton, and tension is upwards. Acceleration is still 3.33 meters per second squared, right? So which means that when you solve this, F equals ma, because it's going up, tension is now more than the weight. So it's T minus 50, giving you a mass of 5, acceleration of 3.33, and you calculate, you should still get about the same answer, which is not 3, upper ni, let's go to this upper, 66.5 Newton. 66.5. I just copied the answer from the book, okay? Let me check. Let me check first. I be tahan. 3.33. 6.65. Okay lah. Let me do the correction. I cannot tahan. Okay, 66.65 then. Should be around there lah, 66.65. That looks more correct. Yep. Even this one also is charted, I think. Right? Right? Let me fix this. Did I have to use a calculator for that? No lah. Let's fix this lah. It's about 36.7. That looks more correct. Yeah. Even this, I think you get what, 36.33. Let me see. 4 times 2.67. 1.35. Oh, 6 points. 36.65 also, right? Yeah, 6.65. Let's fix this. So I just copied us off the book. So yeah, I'm not a fan of the answers in this book. But anyway, so that's how we solve the questions now. All right. So if you have any problems, like I said, just highlight the number, and then we will discuss in the next lesson that I actually see you. All right. Okay, so that's all for this lesson. Okay, practice. All right, next lesson, we're going to go into resolution of forces. Right. Okay, my chair has just moved down and the bell has just rung. Okay, that's all for this video. Hope you found this helpful.